Hey Tech Prim family, welcome back to the channel where we dive deep into tech with tutorials and insight that makes complex topics as easy as scrolling through social media. I am Fulasha Samuel Olayemi, your guide today for a techie adventure into the world of B-trees. Today we are exploring B-tree implementation and visualization in Python. Ever wonder what makes databases and file systems so efficient with huge data? Well, it is B-tree, and by the end of this video, you will know how they work, why they are crucial, and how to build and visualize them with Python and GraphViz. Let's jump in. Before we dive in, here's what you will learn today. How to implement core B-tree operations like insert, delete, and find in Python. How to use GraphViz to visualize B-trees so you can see what is happening as data changes. With these skills, you will understand the underlying structure that powers big data operations. Alright, let's roll. What is a B-tree? A B-tree is a balanced search tree designed to handle massive data, unlike a binary tree. Each node in a B-tree can hold multiple keys and has multiple children, which make it super efficient for databases and file systems. Why B-trees? Well, they able search, insert, and delete data with impressive speed, even with big data volumes. Think of B-trees as the secret weapon behind systems like MySQL, PostgreSQL, and even NTFS file systems. B-trees are not just theoretical, they are everywhere. They are used in databases to index and retrieve data efficiently. They are used in file systems like NTFS and HFS Plus to manage metadata. They are also used in virtual memory to speed up memory page access. Likewise, they are also used in search engines to index huge data sets quickly. With operations like search, insert, and delete running at O log n time, B-trees ensures first access even in storage-constrained environments. They are not just trees, they are powerful data organizers. Now let's look at the nitty-gritty of B-tree operations. Search operation quickly finds keys in O log n time, while the insertion operations add a new key while maintaining balance, even if it means splitting nodes. And the deletion operation removes keys without disrupting structure. Sometimes merging or redistributing nodes is necessary. Likewise, space complexity, ON, ensuring we efficiently use storage while managing data. Now that we know B-trees basics, it's time to visualize. We will use GraphViz, an awesome tool that transforms data structures into images so you can see exactly how data is organized. GraphViz lets us see how B-tree grow and adapt as we add or remove data. First, install GraphViz with these commands. For macOS user, use brew install GraphViz, while for Linux user, use sudo apps install GraphViz, and for Windows user, download from the official site graphviz.org. So to check the version, run .version to confirm GraphViz is good to go. Here comes the code. This is how to set up your nodes and B-tree classes in Python. Each node stores keys and references to child nodes. Next, our B-tree class will handle functions like insert, find, and delete to keep the tree balanced. Our insert function ensures the B-tree maintains balance even if a node gets too full. Here, each insertion checks for overflow. If there is too much data, we split nodes to keep everything balanced. That is how we make sure the B-tree structure remains efficient and ready for fast searching. To find a key, we traverse the tree by comparing each key and branching to the right side nodes as needed. This function is designed for optimal speed by minimizing the number of comparisons, perfect for searching large data sets. Deletion in the B-tree is a bit tricky. After removing a key, we may need to redistribute or merge nodes to keep balance. Deleting from a B-tree is complex but essential for efficient data management. Redistributing nodes ensures that searches remain first even after we remove data. We bring this B-tree to life using Gravis. This could create a visual representation of the B-tree structure. Now, we can view our B-tree as a clean graphical hierarchy with each node connected to its children. Visuals help us spot our potential imbalances instantly. Let us bring our B-tree to life with Gravis. We visualize the B-tree after operations like insertion and deletions to understand its structures better. This is what our B-tree structure looks like visually. Each node is displayed with its keys, and child relationships are shown with arrows. This makes it easy to interpret the structure and validate the B-tree balance. Each console output line represents a level in the tree, showing the keys and node structure in a simplified text format. We also search for key 15 in the current B-tree structure. The function finds 15 in the nodes containing 12, 15, and 17. The output confirms the node location, helping verify correct tree traversal. After a deletion, this structure reflects how B-trees reallocate or merge nodes to keep the tree balanced. To wrap up, here's what we covered today. How B-trees work, which includes insertion, search, and deletion operations. We also cover how to visualize B-trees with Gravis. Seeing really is believing. Lastly, we also cover the benefits of B-trees. They are efficient, balanced, and perfect for big data applications. With these skills, you are now equipped to work with B-trees in both code and visualization, making you a superstar for data-heavy applications. Thanks for watching TechBrain Farm. Don't forget to like, subscribe, and share if you enjoyed this video. Drop your questions or suggestions in the comments and stay tuned for more tech awesomeness on TechBrain. Until next time, keep coding, keep visualizing, and keep growing your tech skills.